before light, before sound. Before time itself had the privilege of flowing, there was only silence. Not the kind of silence you hear in a room after the music stops, but a silence so complete that even the concept of hearing did not exist. No stars shimmered in the distance. No gravity bent the fabric of space. There was not even space to bend. Reality, as far as we can imagine, was an unspoken thought, a void without dimension, color, or form. Yet within that emptiness, something stirred. A potential. A whisper. The faintest tremor in the sea of nothing, too subtle for language, too profound to be denied. It was from that stillness that everything, every atom, every galaxy, every breath you have ever taken, would one day emerge. But if there was truly nothing, then how could anything at all begin? We are taught to think of beginnings as moments, events marked by a before and an after. But the universe refuses to play by our grammar. When we speak of the Big Bang, we imagine a colossal explosion flinging matter and light across a dark void. Yet that picture is a lie of comfort. There was no explosion because there was no space for anything to explode into. There was no before because time itself was born in that instant. The Big Bang was not a bang at all. It was an awakening. Space expanded from a single, infinitesimal point, and in that expansion, the very notion of time was written for the first time. To ask what came before the Big Bang is to ask what lies north of the North Pole. The question itself collapses under the weight of its own paradox. Still, the question persists. It haunts us precisely because it should not exist. Our minds are creatures of cause and effect. We cannot imagine an event without a reason, a spark without a flint. And so, we push the boundaries of knowledge until they blur into mystery. Physicists tell us that in the first 10 to the power of -43 seconds, known as the Planck epoch, the laws of physics as we know them simply stop working. Gravity, energy, and quantum mechanics melt together into something we cannot yet describe. We can simulate the birth of galaxies, trace the echo of cosmic microwave background radiation, and measure the faint fingerprints of time itself. But when we look beyond that first instant, our equations go blind. There, in that unseeable horizon, lies the greatest question ever asked. How does existence emerge from absolute nothingness? Nothingness, however, may not be as empty as it seems. In quantum physics, even a perfect vacuum seethes with restless energy. Particles appear and vanish, borrowing existence from the void before collapsing back into invisibility. The fabric of nothing is not flat. It ripples with potential, like an ocean whose surface hides invisible storms. Perhaps the Big Bang was one such storm, a spontaneous fluctuation that became self-aware, expanding into the reality we now inhabit. To the human mind, that sounds like magic. But in the language of physics, it may be the most natural thing imaginable. Nothing, it turns out, is not truly nothing. It is the womb of everything, a stage so delicate that even emptiness cannot stay still. And so, we stand at the edge of understanding, staring into a void that may not be a void at all. The deeper we look, the more reality seems to shimmer between existence and non-existence, between logic and awe. Every photon, every law of physics, every thought in your mind traces its ancestry back to that impossible moment when being was born out of non-being. To ask what came before the Big Bang is to confront the limits of not just science, but imagination itself. Maybe the answer is not hidden in equations or telescopes, but in the quiet recognition that nothing and everything are two faces of the same mystery. one we were never meant to fully solve, only to feel. Perhaps that is the true paradox. The universe does not simply exist. It questions, it reflects, it dreams through us. We, who are made of stardust and silence, are the living echo of that first awakening. Every heartbeat, every thought, is a continuation of the same miracle that broke the symmetry of nothingness. And maybe that miracle was never about creation at all. Maybe it was about awareness, the moment the void realized it could see itself. In the beginning, there was nothing, and in that nothing, the universe learned to ask why. In the beginning, there was no explosion, only expansion. No roar of fire, no shrapnel of stars bursting through the void. Instead, space itself began to stretch, like an invisible fabric unfolding from a single point smaller than imagination could contain. There was no outside for this event to happen in, because the event was the birth of outside itself. The Big Bang was not a detonation in space. It was the birth of space, of time, and of the possibility of existence. Every direction became a direction for the first time. Every moment became a moment. Within less than a heartbeat of cosmic time, the universe began to write its own autobiography. Its first memory, etched not in ink, but in energy. At around 1/1,000,000,000th of a second after this beginning, the universe was a sea of pure radiation, dense, blinding, unimaginably hot. Temperatures reached 10 to the power of 32 Kelvin, where matter as we know it could not yet exist. In this furnace of creation, the rules of physics trembled on the edge of chaos. Quantum fields danced wildly, colliding, merging, and splitting apart. Gravity, electromagnetism, and the strong and weak nuclear forces were still one and the same. A single elegant law waiting to fracture into the four forces that now sculpt our world. It was the era known as the Planck epoch, where nature itself was too young to differentiate between what would become light, matter, and time. The universe was not yet a place. It was a process, a thought still forming. As expansion continued, the temperature began to fall, fraction by fraction, atom by atom. What had been a blinding fog of energy started to cool enough for matter to imagine itself into being. Tiny fluctuations in the quantum fields, imperfections smaller than a proton, became seeds of structure. These subtle irregularities, born of randomness, would one day grow into galaxies, stars, and planets. From chaos came the blueprint of order. The universe, in its first breath, encoded memory into the very shape of its expansion. Each wave of energy, each oscillation of quantum foam carried information, tiny whispers of what the cosmos would later become. In that moment, the universe was not only expanding, it was remembering. Imagine standing at the edge of that first light, not the warm light of a sunrise, but the violent shimmer of existence itself coming into focus. The young universe was opaque, thick with plasma and radiation. Light could not travel freely. It scattered endlessly off free electrons, trapped within a cosmic fog. Yet hidden in that chaos was a story unfolding, one of symmetry, breaking, and cosmic differentiation. Gravity began to take its own form. The strong nuclear force clenched protons and neutrons together. The weak force governed decay and transformation. And electromagnetism lit the stage for all that would shine. The universe was setting its laws, testing its own logic, sculpting the framework it would use to evolve. In those first moments, creation was not an act of chance. It was an act of memory, of the cosmos learning the rules by which it would play. Billions of years later, when we peer through telescopes at the faint glow of the cosmic microwave background, we are seeing those first memories frozen in time. The light that fills the night sky is not merely illumination, it is recollection. Every photon that strikes your eye tonight has traveled for over 13 billion years, carrying with it a trace of that ancient dawn. To witness the universe is to witness its memory. To ask what happened at the beginning is to listen to the cosmos remembering itself again and again through every star that burns, every planet that forms, every mind that dares to wonder. The universe did not begin with a sound. It began with a memory, a quiet realization that something could be, and that being itself was worth remembering. There is a horizon beyond which our language falters. We call it the beginning. We imagine heat, brightness, and a roar that never needed air. In truth, it was stranger. The early universe was not a place filled with flames, but a state in which space itself was incandescent, a storm of radiation so thick that light could not travel even the breadth of an atom. Every direction was the same. Every moment was the same. A wall of fire, not because fire raged within a room, but because the room itself was still being built. We look back with our mathematics and with our machines, and we approach an edge. Things grow clearer, then harsh, then undefined. The closer we come to the first instant, the less our finest equations behave. They whisper at first, then they stutter, then they fall silent. General relativity describes the grand sweep of space-time with a poet's certainty and a clockmaker's precision. It turns gravity into geometry and planets into dancers whose steps are set by curved floors. It is magnificent. Quantum mechanics rules the small with probabilities and symmetries, threading uncertainty through the core of reality and making the void hum with possibility. It is astonishing. Each theory is a cathedral. Each has been tested again and again by experiment and has not broken. Yet when we carry these cathedrals into the same valley, into the furnace of the earliest universe, their stone arches collide. The one speaks in smooth curves, the other murmurs in granular quanta. Together, at the point we call the origin, they refuse to share a common grammar. Physicists give a name to this refusal: the singularity. It is not a place inside the universe, but a boundary of description, the point at which our map dissolves into white space and warning letters. At time equals 0, the equations of general relativity predict densities and curvatures without limit. Infinity is not a measurement. It is a confession that the method has failed. Quantum mechanics protests, for nothing can be pinned to an exact value, and nothing can be compressed without the foam of uncertainty pushing back. The result is a paradox framed in fire. When the universe was smaller than any meaning of the word small, our two greatest theories, flawless on their own ground, contradict each other. The wall is not only hot, it is logical flame. How do we see such an age when light itself could not pass through it? The answer is that we do not. We see its afterglow. Long after the first moments, when the universe cooled enough for electrons to settle into the arms of protons and for atoms to form, light finally slipped free and began its long journey. That ancient radiance, stretched into microwaves by the breath of expansion, now bathes the sky with a near-perfect uniformity, punctuated by tiny ripples. Those ripples are the fossil fingerprints of earlier turbulence. They are faithful, and they are finite. They let us read the script back to a certain page, and then the pages blur. We press our inference hard against that blur, and we call the blur the wall of fire. Stand before a mirror with the sun behind you. You will not see the sun itself. You will see light borrowed and bounded by the mirror's frame. In the same way, when we ask about the first instant, we are looking by reflection. Our measurements, our particles, our telescopes, all of them are mirrors that return an image shaped by their own limits. Beyond that shine lies the source we cannot quite face. If we push the mirror closer, its frame takes more of the view. If we push our theories closer, their assumptions occupy more of the answer. The picture sharpens and then saturates. It is not darkness that stops us. It is brilliance. Too much energy in too little meaning. Too much curvature in too little space. So we search for a bridge. We give it many names: quantum gravity, loop networks, strings that vibrate through hidden dimensions, emergent space-time from entanglement. Each attempt is a promise that continuity and discreteness can be reconciled. Each is a hint that the wall is a veil and not a cliff. Perhaps space-time is not fundamental, but woven from relationships between quanta. Perhaps the singularity is replaced by a bounce, a passage, or a smooth rounding where time behaves like a spatial direction and the word before loses its sting. We do not know. What we do know is this: the wall of fire marks the limit of our understanding, not the limit of reality. And at that limit, the universe asks us a question that sounds like a prayer. If time was born, what existed when time was unborn? Long before galaxies swirled or atoms found their balance, there was the quantum sea. It was not calm, it was not silent. What we call emptiness, the vacuum of space, is, in truth, a storm without surface. Even in perfect darkness, reality hums. Energy flickers into being, then vanishes, leaving no trace except a pulse in the fabric of space-time. Physicists call these events quantum fluctuations. To the eye, they are invisible. To the equations, they are everything. They are the restless breathing of nothingness. And perhaps, from one such breath, our entire universe was born. In quantum mechanics, emptiness is never truly empty. The vacuum is a field, not a void, a web of potential energy that cannot reach zero. Uncertainty forbids stillness. Even when all particles disappear, the fields that give them birth continue to vibrate, a symphony played in silence. Virtual particles emerge, dance briefly, and annihilate each other, borrowing energy from the void and repaying it before the universe can notice. This is not myth, but measurement. We see its fingerprints in the Casimir effect, in the way space itself exerts pressure on two parallel plates. From this shimmering ocean of nothing, creation is not a miracle, but a statistical inevitability. Imagine the quantum vacuum as a sea so dense with possibility that it can never rest. Each ripple represents a potential universe, a pattern of energy and law that might blink into self-sustaining existence. Most vanish in an instant, collapsing before they have time to define what time means. But once in a while, perhaps once in eternity, a fluctuation grows large enough to fold back on itself. Its own gravity traps the energy it has borrowed. Expansion feeds expansion, and from that feedback, space begins to inflate. No trigger, no divine command, only a fluctuation that refused to fade, a quantum breath that became a cosmos. To grasp this is to abandon the old comfort of cause and effect. There was no before in the human sense, no clock waiting to start ticking. The quantum breath did not happen in time. It created time. Its oscillation was the first rhythm, its expansion the first beat. With each wave, the universe doubled in size again and again, faster than light, filling itself with energy and potential. What we call the Big Bang may not have been the start of everything, but the first sustained note in a cosmic vibration that had been echoing forever in quantum silence. In that sense, creation is not an act, but a resonance. Some physicists see in this idea a strange kind of symmetry. If particles can appear from nothing and return to it, then existence and non-existence are equal halves of a single equation. The universe might balance perfectly, its total energy summing to zero. Positive energy in matter and radiation offset by negative energy in gravity. From that accounting, the cosmos costs nothing to exist. It could arise spontaneously, unprovoked, without violating a single law of physics. To be, then, is not to break the rules, it is to express them. What we call creation may simply be the universe's most natural state, the self-organization of possibility. And yet, behind every explanation, there lingers awe. We can write equations for fluctuations, but not for wonder. We can calculate probabilities, but not meaning. When we speak of the quantum breath, we are describing not just a mechanism, but a mystery, the moment the void inhaled and found itself full. Perhaps that breath continues still, in every vibration of every atom, in every thought that wonders why. The universe may have begun as a fluctuation, but it endures as a question. If the quantum vacuum is never truly empty, then nothingness itself is fertile, and we are the fruit of its first trembling breath. Imagine a vast ocean with no shore, no horizon that stays still, no surface that ever rests. This is the image that cosmology offers when it speaks of eternal inflation. Not a single beginning, not a single burst. Instead, a field of energy that refuses to relax everywhere at once, causing space itself to swell at a rate beyond ordinary comprehension. In this picture, our familiar universe is not the whole sea. It is a single wave crest, a local calm after a global storm. What we call the Big Bang becomes a regional event, a pocket where the inflating field dropped into a quieter state and released its energy as matter, radiation, and the heat that would later cool into the first atoms. The ocean, however, keeps rising elsewhere. It never finishes. It never sleeps. Physicists give the driving role to a field sometimes called the inflaton, a landscape of energy perched above its most stable resting place. As long as the field sits high on that landscape, space expands exponentially, doubling upon doubling in a rhythm that outruns any signal, any particle, any light. But quantum physics adds a twist. The field does not roll down smoothly. It jitters, it foams. Fluctuations nudge it lower in some patches while holding it up in others. Where it falls, inflation ends locally, and a hot birth begins. Where it clings, inflation continues and space races ahead, creating more volume in which further patches can fall. The result is a self-reproducing process, creation branching within creation, pockets of fire budding inside a cold, relentless bloom. Each pocket is a bubble universe. Inside, the violent energy of the falling field reheats into particles and light. The familiar laws of physics crystallize from the cooling. Space stops inflating and begins the slower expansion we observe today. Outside the bubble, inflation still surges, stretching distances so quickly that no traveler, no photon, could ever cross the gulf. Bubbles drift apart faster than causality can bridge. They may never meet. From the viewpoint within, each bubble carries its own sky, its own timeline, its own chance to form galaxies. What we call the cosmos is simply our bubble's interior history. A small room in a palace with uncounted halls. Because the inflating field can drop into different resting places, the properties of each bubble may differ. the masses of particles, the strength of forces, even the number of large spatial dimensions in some adventurous theories. This is where the concept becomes unsettling and strangely intimate. We look at the fine balance that allows stars to shine long enough for life to arise, and we wonder whether our local laws were selected by necessity or by survival. Perhaps there are countless bubbles in which chemistry fails, in which gravity crushes too quickly, in which light never lingers. We would not be there to notice them. We awaken where the conditions allow questions to be asked. The sea does not favor us. It merely contains us. Eternal. Inflation carries puzzles of its own. How do we define probabilities in a process that never ends? The measure problem rises like fog on the water, blurring statements about what is typical. Collisions between bubbles might leave scars upon the microwave sky, yet the ocean's expansion can hide such marks beyond reach. Even so, the framework explains much with one audacious idea. A brief era of runaway expansion smooths space, flattens geometry, and plants the quantum seeds that later grow into galaxies. The same fluctuations that jostled the inflaton also imprinted a delicate pattern of density, a whisper we still observe. Order from roaring growth, structure from a storm. Stand at the edge of a dark shore and listen. The surf is endless. Waves rise and fall, but the ocean persists. Eternal inflation suggests a universe with that same inexhaustible rhythm. Local endings, local beginnings, global continuation. Our sky is a memory of one bubble's first light. Our questions are the salt left on its wind. Perhaps creation is not a single trumpet blast, but a choir without finale, each voice a bubble, each harmony a set of laws, each silence a space still inflating beyond sight. If so, the deepest wonder may be simple and humbling. We are not the center of the sea. We are a crest upon it, and the sea goes on. Every end suggests a beginning. Stars burn out so that heavier elements can be born. Galaxies collide, then settle into new forms. Even on Earth, forests die and return through the quiet patience of soil. It is tempting, then, to imagine that the universe itself might share that rhythm, a cosmic heartbeat, expanding and contracting in endless repetition. The idea of a cyclic universe proposes just that, an eternal alternation between birth and collapse, between fire and silence. Perhaps the Big Bang was not the first, nor will it be the last. What we see as creation could simply be the rebound of a previous age, the inhalation after a cosmic exhale. Time, in this vision, is not an arrow, but a pulse. In a cyclic model, the universe expands for billions of years, its galaxies drifting apart until gravity weakens to a whisper. Eventually, dark energy, whatever it is, might lose its hold. Expansion could slow, then reverse. The galaxies would begin to move closer once more. Temperatures would rise. Matter would compress. In its final contraction, every atom, every photon would rush toward reunion, the cosmos collapsing into an almost singular point, dense beyond measure. Yet at the brink of oblivion, when entropy should reign, quantum physics might intervene. Instead of ending in a perfect zero, the universe could bounce, space unfolding again, time uncoiling into a new eon. Death transformed into birth, not by miracle, but by the stubborn logic of cycles. There are many shapes this rebirth could take. Some theories imagine a graceful rebound, others a violent renewal in which the debris of the old universe seeds the next. In ekpyrotic cosmology, our Big Bang might have been triggered by the collision of higher dimensional membranes, immense sheets of reality brushing together in a higher space. Each collision is a blaze of creation, each retreat a long cooling age. From that perspective, the cosmos does not live once, but endlessly rehearses its own becoming. What we call before is just another turn of the wheel, another cycle buried beneath the ashes of expansion. Existence, then, is not a straight story, it is a spiral. Yet there is another vision, quieter and more radical. In the 1980s, Stephen Hawking and James Hartle proposed what they called the no-boundary universe. It suggests that time itself is curved, much like the surface of the Earth. On a globe, there is no edge, no point where you can step off into nothing. Move far enough north, and you arrive at a pole, not a wall. In the same way, the universe may have no boundary in time. The Big Bang would not mark a beginning, but a smooth, rounded region where the distinction between past and space dissolves. Asking what came before becomes meaningless. There is no before, only a direction in which time loses its shape. The cosmos did not start, it simply is. This idea is difficult to hold in the mind. Our intuition craves beginnings and endings, but a no-boundary universe denies both. It is self-contained, finite yet unbounded, like a melody that closes upon its own first note. In such a model, the laws of physics describe not an explosion, but a transition from a purely quantum state into the classical reality we inhabit. The early universe might have been timeless, governed not by events, but by probabilities, a fog of potential that crystallized into history. To cross that threshold was not to ignite a flame, but to let structure emerge from stillness. Much as dawn does not begin the day, it reveals it. Whether the universe breathes in cycles or curves without edge, both visions share a quiet revelation. The question of before may itself be misplaced. Time may not be the stage on which the universe unfolds, but one of its actors, born, transformed, and perhaps reborn. The cosmos could be eternal not in duration, but in continuity, a pattern that persists even as each version fades. We may be living in one inhale of that eternal breath, a momentary sparkle in the lungs of infinity. Perhaps the universe does not begin and end at all. Perhaps it simply remembers how to return, again and again and again. Begin with a wall, not brick or stone, but a boundary of space-time, a quiet horizon where light hesitates and time slows into a long breath. Imagine that everything within a region, the stars, the dust, the heat, the very equations that choreograph their motion, could be summarized on that boundary like ink pressed into a seal. This is the audacious suggestion of the holographic principle. What appears three-dimensional may be fully described by information inscribed on a two-dimensional surface. Depth becomes description. Volume yields to area. It sounds like poetry wearing a lab coat, yet it was born from the most unforgiving place in physics, the edge of a black hole, where gravity becomes geometry and information faces its severest trial. We expect mysteries there. We did not expect a library carved into the horizon. Black holes teach harsh lessons with perfect clarity. Feed a star to the darkness, and almost everything you knew about the star disappears behind the horizon. Mass remains. Charge and spin might remain. The rest is silent. That silence once suggested that information could be lost forever, dissolved by gravity into a featureless night. But thermodynamics fought back. If a black hole has a temperature and an entropy, then it is a physical object with a countable number of internal states. Its entropy does not scale with its volume as ordinary matter does. It scales with the area of its horizon. The more closely you examine the mathematics, the louder the message becomes. The bookkeeping of reality at the edge depends on surface, not interior. The horizon is not merely a boundary, it is a ledger. Then came the whisper of quantum mechanics at the horizon's lip. Hawking showed that black holes are not perfectly black. Quantum fluctuations near the boundary allow pairs of particles to flicker into existence. One escapes, one falls. Over vast times, the whole radiates away its mass, a slow exhalation of information disguised as heat. This created a crisis. If the radiation is purely thermal, structure dies and information is lost. If information is not lost, the radiation must carry a hidden pattern. The paradox sharpened the holographic idea. The horizon must encode the microstates well enough that the outward glow can, in principle, return them to the universe. Entropy, temperature, and geometry close ranks and hint that spacetime itself computes. What falls in is not erased, it is rewritten on the skin of gravity. From this brink rose a bridge. In certain universes curved like a saddle, a precise duality relates a world with gravity in the interior to a world without gravity living on the boundary. The boundary theory is quantum, microscopic, and exact. The interior is classical in the limit, geometric and vast. Every event in the bulk corresponds to a pattern of fields at the edge. Every ripple of space-time echoes as correlations on a cosmic screen. In this correspondence, the area of certain surfaces in the interior measures entanglement on the boundary, as though geometric lengths are woven from quantum links. The lesson deepens the metaphor. Space may emerge from information. Distance may be the shadow of entanglement. Where bonds are strong, geometry knits tight. Where bonds are cut, space-time frays. Think of information now as the true currency of existence. Particles are tokens. Forces are exchange rules. Entropy is the counting of possible stories that microscopic degrees of freedom can tell. When we study the faint afterglow of the early universe, we read a record of correlations laid down when everything was young. When we map dark filaments across the cosmic web, we track the flow of information shaped by gravity. Even consciousness, cautious as we must be, can be viewed as patterns of information moving through a biological lattice, a local hologram reflecting a larger code. The holographic view does not deny matter, it demotes it. Matter becomes one way that information chooses to appear, like a wave choosing a shore, like music choosing a key. Stand before the night and let your eyes adjust. The sky is a page, and every star a letter in an alphabet that began before memory. Perhaps what we call reality is the inside of a book whose cover is the horizon, and reading is the act of decoding correlations written on the edge. If this is right, then the deepest laws of physics are not about things, but about statements that can be made about things. Not about substance, but about relations. Not about points, but about patterns. The universe may be a hologram, yes, but more profoundly, it may be a story encoded at the border of being, and then projected inward as world. If matter is a chapter and energy is a plot, then information is the language, and the cosmos is what the language means when it learns to speak itself. Every photon that has ever escaped a star still travels. It never stops, never grows tired, never forgets where it came from. Across the immensity of time, these messengers carry with them the imprint of their birth, the temperature of the gas that forged them, the motion of the atoms that released them, the gravitational wells that bent their paths. To look into the night sky is to read an archive written in light. The universe is not silent. It hums with memory. Each quantum interaction records a trace. Every collision leaves a fingerprint. Information, as far as we can tell, is indestructible. It may scatter, it may entangle, it may hide behind horizons, but it is never truly lost. The cosmos, in its own quiet way, remembers everything. This idea lies at the heart of quantum mechanics. The laws that govern the smallest scales are reversible, like perfect mirrors. If we knew the exact wave function of the universe, the grand equation that describes every particle, every field, every vibration, we could, in theory, rewind it to any moment and recover what once was. The past is not erased. It is woven into the current state of the whole. Even when systems appear to lose coherence, when entropy rises and order decays, the information merely becomes scrambled, distributed among countless correlations too complex to decipher. Like ink diffused in water, the message does not vanish. It becomes everywhere at once. Black holes once seemed to defy this rule. Anything that crossed the horizon appeared to vanish without trace, a total erasure forbidden by quantum law. But if the universe respects information, then even the darkest abyss must find a way to keep its books balanced. The resolution, physicists now suspect, lies in the most delicate of encodings. The horizon itself acts as a memory surface, storing data in microscopic ripples of geometry. When the black hole evaporates through Hawking radiation, that information leaks back into the cosmos, encrypted in the faintest fluctuations of heat. The paradox becomes revelation. Gravity is not a thief. It is a librarian, keeping immaculate records in the language of quantum bits. If that principle is true everywhere, then the universe itself is a vast memory field. The cosmic microwave background, the oldest light we can observe, is a snapshot of conditions nearly 14 billion years ago, frozen into the sky like the faint afterimage of a dream. Its subtle anisotropies, its tiny variations in temperature, are not noise, they are history. Each pattern encodes the quantum tremors of the newborn cosmos, the earliest whispers of matter and structure. In those patterns lies the story of every future galaxy, every cluster, every star. Even the voids between them remember the dance that shaped them. Space is not an emptiness. It is the hard drive of reality. The principle of information conservation also changes how we think about time. If nothing is ever truly lost, then the arrow of time is not about destruction, but about unfolding. Entropy is the spreading of memory, not its erasure. The universe forgets nothing. It only hides its recollections in deeper and subtler forms. Somewhere in the correlations between particles, in the entanglement that binds distant regions of space, the echoes of every event still reside. Perhaps, if we could read the quantum fabric with infinite precision, we could reconstruct every sunrise, every supernova, every breath ever taken. The past would not be gone. It would simply be inaccessible, like a book whose pages have been scattered through an infinite library. To live in such a universe is to exist inside a memory that never fades. We are patterns of information drawn from the same code that records the birth of galaxies. The atoms in our blood remember the death of stars. The light in our eyes remembers the first dawn. When we look outward, we are also looking backward, into the preserved story of everything that has ever been. And if this law of remembrance is truly universal, perhaps it extends even beyond our own cosmic chapter. Perhaps the universe we inhabit is itself a recollection, an encoded echo from a cycle before time began. If information is never lost, then we are not living at the beginning of creation. We are living inside the memory of another cosmos. Step outside on a cold, clear night and raise your eyes. The light that pours into them is ancient. It crosses gulfs that words can barely hold, drifting through interstellar dust, skirting the gravity of unseen masses, slipping finely through the thin glass of your corneas to touch the fragile film of your retina. It feels immediate. It is anything but. Each photon is a traveler with a story, launched long before our language, long before our cities, long before our species imagined itself separate from the sky. You and the night are not strangers. You are correspondents. The cosmos writes in light. You read with living tissue. For a heartbeat, you are the page. In that exchange, something quiet and astonishing happens. The past looks back. Astronomy is a kind of time travel practiced with mirrors and patience. Because light has a finite speed, every distant object is also a former self. A galaxy is not shown as it is, but as it was when its photons began their journey. Even the calm, uniform glow that fills all directions, the relic whisper of the first fire, is a letter mailed from the universe's childhood and only now arriving. We call it a background, but it is more than scenery. It is a record. Redshift measures the stretching of wavelengths by the swell of space, a chromatic timestamp that turns color into chronology. Look farther, and you look earlier. Peer deeper, and you breach older chapters. Telescopes do not simply magnify distance, they magnify memory. Light remembers more than time. It remembers gravity. As it passes near massive structures, its path curves, not because it bends like a leaf in wind, but because space-time itself is arched by mass and energy. The result is lensing. Distant galaxies smeared into arcs, multiplied into mirrored flames, rearranged into delicate rings. These distortions are not errors. They are annotations in the margin, notes about the invisible scaffolding that shaped the beam. Dust imprints its fine signature as well, scattering the bluer notes, letting red tones slip through. Gas clouds etch dark lines across spectra, each line a barcode for a particular atom dancing at a particular temperature. Light is therefore not mere illumination. It is evidence. It is testimony. It is the sworn affidavit of matter and gravity under oath. And yet, the most remarkable instrument in this exchange is not the observatory on a mountain or the mirror that floats beyond the atmosphere. It is your eye. Rods and cones sit in quiet darkness until a single photon arrives to tilt a molecule and trigger an electrical cascade. One quantum, one change, one signal rushing along a nerve toward the theater of the mind. Vision is a biology of thresholds, a living amplifier that converts the faintest cosmic currency into experience. Even the neurons that interpret the signal carry a map of the world learned over a lifetime, so that what you see is never just what arrived, but a synthesis of memory and light. The universe sends a messenger. The brain writes a story. We call that story seeing. It is also remembering. Stand beneath the Milky Way and consider the improbable chain behind that moment. In some remote spiral arm, a star forged calcium in a furnace of pressure and time, then died and scattered the element across a nursery of gas. A later star, gentler, gathered planets, and one of those planets learned chemistry's rarest grammar. Molecules folded into metabolism. Metabolism discovered nerves. Nerves discovered music and mathematics, and the urge to ask questions that outlive the answerer. Now, a photon that left a distant region during an era of giants completes its journey in the back of a primate eye, and in that tiny arrival, the universe completes a loop. Matter becomes mind. Mind becomes witness. Witness becomes meaning. A circle closes with the softest click imaginable. When we say that the night is beautiful, we are not only praising starlight, we are recognizing a conversation more durable than stone. The past is not gone, it simply travels. It crosses the vastness and returns as radiance, as faint heat, as a whisper dressed in color, and we, brief as we are, make room for it. Perhaps that is the essential act of consciousness, to let reality echo within us until it becomes understanding. Perhaps that is the true romance of science, to love the world enough to listen when it speaks softly. The light we catch is not just the universe that was. It is the universe learning to see itself through us at last. When you look up, do not only look outward, the light is looking back, and in that gaze the cosmos remembers its own name. Somewhere in the long, cold history of the cosmos, a flicker occurred. Not the birth of a star, nor the collision of galaxies, but something quieter, stranger, more intimate. Matter began to notice itself. After nearly 14 billion years of expansion, of cooling and coalescing, the universe opened its eyes through a nervous system of carbon and water and electricity. What began as quantum fields vibrating in emptiness had learned to feel, to think, to wonder. It is a transformation so extraordinary that we often forget what it implies. Consciousness is not separate from the universe. It is the universe, rearranged, becoming aware of its own existence. We are not observers standing outside of creation. We are its self-reflection. At the root of every conscious moment is a symphony of physical processes. Electrical signals race across neural networks. Ions move, molecules align, patterns synchronize. Each neuron is a microscopic switch, yet the mind that emerges is more than the sum of its switches. Complexity breeds awareness. Somewhere between simplicity and chaos lies a threshold where matter begins to experience itself not only as matter, but as mind. Physicists call it emergent behavior. Biologists call it life. Philosophers call it miracle. From the self-organizing laws of the early cosmos came systems capable of pattern recognition, memory, and anticipation. Life became a feedback loop of perception, an instrument through which the universe could record and respond to itself. When we peer into the human brain, we find an architecture that eerily mirrors the cosmos that made it. Billions of neurons, each linked by filaments, forming networks of clusters and voids. Their organization echoes the large-scale structure of galaxies, luminous nodes connected by filaments of dark matter, spanning unimaginable distances. Both systems grow through self-organization, following the mathematics of connection and feedback. Both evolve toward efficiency in transmitting information. Perhaps this is not coincidence, but principle. Perhaps the same underlying rules that sculpted the cosmic web also sculpted the neural web behind our eyes. To look at the stars, then, is to glimpse a pattern we already carry within. If consciousness emerges from complexity, then it may not be rare. It may be woven into the logic of evolution itself, arising wherever the cosmos achieves sufficient intricacy to model itself. On worlds with liquid water and stable suns, chemistry plays its slow music, building structures that store and process information. From that music, awareness rises, tentative at first, then articulate, then reflective. In that sense, intelligence is not an anomaly, but a phase transition, as natural as fusion in the heart of a star. Through each mind that forms, the universe refines its understanding. Through every eye that opens, it expands its perception. Through every question asked, it deepens its memory. To call this romantic is not to make it untrue. The equations of physics do not forbid meaning. They merely describe its stage. Entropy drives the spreading of energy, but within that spreading, islands of order bloom. Each living cell defies entropy for a time, gathering information, creating structure. Each conscious being extends that defiance into imagination, into art, into love and curiosity. These are not accidents of evolution. They are consequences of the same natural laws that forged stars. The hydrogen that once burned in stellar hearts now burns as thought. The light that once illuminated galaxies now illuminates understanding. We are not separate from the fire. We are what it became when it learned to dream. And so the story of consciousness may be the final chapter of the universe's own awakening. From the quantum foam to galaxies, from atoms to awareness, the arc bends toward reflection. Through us, the cosmos perceives its own beauty, contemplates its own origins, and mourns its own impermanence. We are the mirror in which it sees both its vastness and its fragility. One day, the stars will fade, and even thought will fall silent. But for now, in this brief interval of light and life, the universe knows itself, and that knowing is enough to make existence sacred. The universe needed a mirror to see itself, so it built life, and through that mirror, it finally opened its eyes. All stories long for an ending. Every journey seeks a return. Yet when we trace the path of the universe back to its first light, when we push our equations to the limits of time and matter, we arrive not at an answer, but at a silence. The silence is not empty. It is charged, waiting, alive with the hum of something that cannot be solved. We call it mystery because we cannot bear to call it truth. What if the universe was never meant to be understood in full? What if its purpose was not to be a statement, but a question, an eternal act of curiosity expressed in stars, in atoms, in minds that forever ask why? The more we learn, the deeper that question becomes, winding through every scale of being. Like a refrain, the cosmos never stops singing. Science, for all its precision, has always been a form of wonder wearing a disciplined face. Every discovery opens a door only to reveal another hallway. We thought the atom was indivisible until it wasn't. We thought time flowed evenly until it bent. We thought the universe had a beginning until we saw hints that it might not. With every truth comes the whisper of a deeper one beyond reach. Knowledge expands, but the horizon of ignorance expands faster. Perhaps that imbalance is not a flaw, but the engine of meaning itself. The universe questions through us, using our curiosity as its own voice. We are the language of its restlessness, the consciousness of its unfolding. There is a quiet paradox here. If the cosmos contains everything, then there is nothing outside it to ask what it is for. Yet here we are, inside it, built from its dust, wired by its laws, and we ask anyway. Our questions reach beyond our scale, beyond the briefness of our lives, as if the act of asking were itself a rebellion against entropy. To wonder is to defy the odds of existence, to push back against the indifferent mathematics of chance. Every time a mind looks up at the night sky and dares to ask, why, something subtle shifts. The cold machinery of the universe becomes aware that it is not just machinery. In our questions, the cosmos becomes conscious of its mystery. Perhaps that is what consciousness was always for. Not to dominate, not to conquer, but to reflect. To serve as the mirror in which the universe could finally see itself thinking. When you ask a question about existence, you are not separate from it. You are the continuation of the same impulse that set the universe in motion. The same tension that pulled light from darkness, order from chaos, being from non-being. In a sense, the Big Bang never ended. It continues in every mind that ignites with curiosity, in every equation written, in every poem whispered under starlight. Creation, then, is not a one-time event. It is an ongoing dialogue between the cosmos and the consciousness it birthed. But questions can be painful. They remind us how little we know, how temporary we are. Stars are patient. We are not. We crave meaning, and yet the universe answers with silence that feels infinite. Still, there is beauty in that silence. It is the same silence from which everything emerged. To listen to it is to feel the shape of your own finitude within something immeasurable. The ache of not knowing becomes its own kind of connection, a recognition that we and the universe share the same hunger for understanding. Maybe that is what it means to exist, to be an unfinished thought in the mind of eternity. In the end, the greatest mystery is not what happened before the Big Bang, or whether time loops or stretches forever. The greatest mystery is that we care enough to ask. The same spark that ignited the first atoms now burns behind your eyes, fueling questions that have no final answer. Maybe that spark is the answer, the living proof that existence is aware of itself. When the stars fade, the questions will remain, echoing in the dark like the universe's own heartbeat. What came before the Big Bang? Maybe the question itself was the first spark of creation, the universe asking itself, softly and endlessly, "Why am I here?" The music is fading. The images slow. What began as heat and pressure and unthinkable brightness has cooled into a sky of patient embers and into minds capable of remembering the fire. We have followed the trail from quantum tremors to clusters of galaxies, from the first light to the inward light of awareness. We have watched gravity bend the path of photons and time itself curl around mass like a river caught by stone. We have named our ignorance with care, and we have turned that ignorance into a compass. It points not to a single answer, but to a deeper listening. For the universe, in its oldest register, speaks softly. It speaks in spectra and in silence, in the near-perfect chill of the microwave background and in the warmth behind the eyes. We stand between those two currents. We are small. We are brief. We are sufficient. From nothing came everything. That is the sentence our language struggles to hold without breaking. Yet physics, stern as it is, allows a way. A vacuum that is not empty. A balance in which the positive energy of matter is offset by the negative pull of gravity, so that the whole may cost nothing at all. Entropy spreads, and still islands of order rise to harvest free energy and write temporary structure against the tide. Stars do this. Cells do this. Minds do this most of all. Meaning is not imposed from beyond. It emerges from relation, from pattern, from the way information knits itself into memory. Perhaps the cosmos does not ask to be worshipped or feared. Perhaps it asks to be understood, and when understanding fails, to be cherished. We will not see the last act. In a future so distant that words lose color, Stars will exhaust their fuel, and galaxies will dim to embers wandering a greater dark. Even then, the past will not be gone. It will linger as a thin warmth, as a faint whisper of radiation, as correlations hidden in the fabric that once flared with suns. The echo will remain, not loud, not gone, simply present, like breath at rest. Between now and that horizon, there is work worthy of our wonder. To read the traces with more faithful instruments, to tend the fragile oases where consciousness has taken root, to bind curiosity to care. The universe learned to look at itself. Our task is to help it keep seeing. So let the credits roll across a quiet sky. Let the soundtrack resolve to a single sustained note, almost below hearing. Walk outside and feel the night lean close, and know that you are not separate from it. You are the story telling itself. You are the light remembering its source. You are the interval in which the question finds a voice. The cosmos will continue whether or not we answer, but it becomes more itself when we try. Accept the mystery, hold the data, keep the awe, and when words are spent, listen. The universe is speaking where sound cannot travel, and the message is older than time. We are the question the universe